Assalamu alaikum students. I hope you all are doing well. Today's topic is identities of complex numbers, modulus and conjugate. These terms modulus and conjugate are directly related with the with complex numbers, and these identities are for complex numbers. So let's start. Identities. There are some identities, mainly 5 identities which we should know about complex numbers so that we can solve the questions related to them. So the first identity is this one. According to this identity, if we add two complex numbers z1 and z2 and then we take its whole square after adding them, then it will be equal to, this is the left hand side and this is the right hand side. Okay, so this left is z1 plus z2 whole square, means two complex numbers are added and then its square, whole square is being computed. Okay, and on the right side, z1 square means square of one complex number, first complex number z1, then the square of second complex number, and then 2 into z1 into z2, and then we are going to add these three terms, z1 square, z2 square plus 2 into z1 plus z2 square. This is the third term. Okay, so when we are going to add these three terms, it will be equal to the left hand side, which is z1 plus z2 whole square. So this is the first identity. Okay, identity means something which is being proven, and we use this term for describing such things such as that left hand side is always equal to right hand side. So here as well we are showing that this left hand side is gonna be equal to this this right hand side. Okay, let's see the second identity. Second one is, this was the first one, this is the second one. Second one is for subtraction, z1 minus z2 whole square. This is equal to z1 square plus z2 square minus 2 z1 z2. Okay, 2 z1 into z2 can be written as 2 z1 z2. Okay, in simplest terms it can be z1 square plus z2 square plus 2 z1 z2. This z1 minus z2 whole square is equal to this term, z1 square plus z2 square plus 2 z1 z2. Okay, the third identity is z1 whole square minus z2 whole square. This is gonna be equal to this one, z1 plus z2 bracket close, this whole term z1 plus z2 is being multiplied with this whole term z1 minus z2. So these two terms, the first one is being summed up and the second one is subtracted. So after the addition and subtraction of the two terms or two complex numbers, we are gonna multiply these two terms. Okay, so this will be equal to the left hand side on which z1 square minus z2 square. Okay, for the fourth one, z1 plus z2 whole cube. These three were for square, firstly for adding and then taking its whole square, then subtraction, whole square, and then whole square of two different complex numbers and subtracting them. Okay, the third one, and the fourth one is for cube of complex numbers. Let me clean the board. Okay, so let us see this one, fourth one. This is z1 plus z2 whole cube. This is the left hand side of this identity. z1 plus z2 whole cube is equal to z1 cube plus 3 z1 square z2 plus 3 z2 square. See, z1 cube first term, second term is 3 z1 square z2 second term, the third term 3 z2 square z1, the fourth term z2 cube. These four terms are added up and then this whole term will be equal to what, left hand side on which z1 plus z2 means through two complex numbers are added and its whole cube is being taken. So this is the fourth identity for complex numbers. The fifth one is z1 minus z2 whole cube. This is also for cube of complex numbers but with subtraction or minus sign. Okay, so it will be equal to z1 cube minus same as this one, z1 cube, and here plus sign is being replaced by minus sign. Z1 cube minus 3z1 square z2 same as this, plus same to same 3z2 square z1 same as this, and then at last again my plus sign is being replaced by minus sign, minus z2 cube. Okay, so these were the 5 identities for complex numbers. Now let us move towards very interesting concepts related to complex numbers. Two concepts are modulus and conjugate. So if we have a complex number which is being denoted, or its notation is this: z is equal to a plus ib. I is for iota. Okay, and iota's value is -1. Okay, you must know this because I have told you in my previous video. Okay, so the concept of modulus is that modulus is represented by this thing z, the complex number, and its modulus is being represented by these two vertical bars on left and right side of z. And what is the formula to calculate modulus of a given complex number z is equal to a plus iota b? The formula is under root a square plus b square. This a has come from here, the real part, and this b is from the imaginary part. Let us take an example for modulus so that it will be more clear. Let us see if we have complex number z is equal to 3 plus 9 iota. Okay, and we are going to take its modulus. We have to find what? Modulus of the given complex number. So z will be equal z modulus, this is modulus, will be equal to what? A square means 3 square plus b square. Here 3 is a and 9 is b, so 9 square. No part of iota, no functionality of iota here for calculating modulus. So 3 3s are 9 plus 9 9s are 81. The modulus will be equal to what? 90. Okay, so this is the answer for this complex number. We have got this under root 90 as its modulus. Okay, we can further resolve it as well for if we want to take its under root value. Okay, so let us move towards conjugate. Conjugate is also really easy. The conjugate of z is represented by z bar. This is its representation or symbol, and the notation is z bar is equal to a minus iota b. In this means in conjugate what we have to do, we just have to change the sign with the imaginary number. Okay, like if we are given this complex number as its basic notation, z is equal to a plus iota b, then its conjugate will be equal to a minus iota b. Only the plus sign has been converted or replaced by minus sign. If we are given a value 27 plus 3 iota, it is z, and we are asked to take or calculate its conjugate, then its conjugate will be really easy. It will be equal to 27 minus 3 iota. Simple. Okay, so this was today's lecture in which we have seen the identities of complex numbers, then modulus of complex number, and conjugate of a complex number. So I hope you have got the point and idea of how to calculate modulus and conjugate. If you want me to solve examples for these 5 identities, you can tell me in the comment section. I will do it for you. If you have any query or question, you can ask me in the comment section. And yes, if you like my videos, kindly like, comment and subscribe to my channel, and share it with your friends so that they can subscribe as well. Thank you so much. Allah Hafiz.